let's have a look at the first question. The question asks calibrate the following models. And the model has y is equal, or the model is y equal to c1 times x to the power of c2. And I have x and y for this model. Calibrate means find the unknowns. And the unknowns here are what? C1 and C2. C1 and C2 are the unknowns, and I'm trying to find the values for the unknowns. So what we have done so far, we have created matrix A and vector B. Do you remember? Matrix A, first column represents what in matrix A? Each column in matrix A represents what?
C1.
Each column represents one of the unknowns. So the first column represents C1. The second column represents C2. When we created A and B, we had a coefficient times C1, right? And the coefficient was known. We didn't have any unknown times another unknown. For example, we had 2 times x plus 3 times y, right? We took 2 and 3, or like 4 times x plus 5 times y. For A, we had 2 and 3, 4 and 5. The first column represents x, the second column represents y. And then 2 is a known. 2 is a known coefficient. X is the unknown, right? But in this case, what is the coefficient of C1? That's C1 times x to the power of C2. So x to the power of C2 is basically the coefficient for C1. Whereas the coefficient already includes another unknown. That can't be. So what we need to do is we need to separate these unknowns from one another. How do I separate C1 and C2?
Creating 2 equations.
What? How do I create 2 equations? Can you think of a transformation that would separate C1 and C2 from one another? Divide by what?
So you see your y divided by C1 equals xC2.
Maybe? No, because that's y divided by C1. C1 is in the denominator. So it's not a linear system with respect to C1. Make sense? Do you remember log? What log does? What is log of A times B? Equal to? Log of A times B is equal to what?
Log A plus log B.
Absolutely. Log A plus log B. What is log of A to the power of B?
B log A.
B times log of A. Now, can I use log to linearize that equation? How do I do that?
C2 log x.
So I need to take log from both sides, right? I have to transform both sides based on log transformation. So log of y is equal to log of C1 x to the power of C2. Then for this, log of y is log of y. For this, I have log of C1 plus log of x to the power of C2. Still not linear. X to the power of C2. C2 should be log of y is equal to log of C1 plus C2 log of x. Is it now a linear equation? Still not, because we have log of C1. But what if I replace log of C1 with, I don't know, for example, D. Instead of log of C1, I put D. D plus C2 log of x. Let me rewrite this here. Log of y is equal to D plus C2 log of x. Right? With respect to D and C2, is it linear or not? With respect to D and C2. That's linear. Now I can create my matrix A. Matrix A will be what? What's the coefficients for D? Ones. Ones of length of x comma 1. What's the coefficient for C2?
Oh no, log.
Log of x is the coefficient for C2. What is D? Log y is D, right? And then if y is horizontal, we need to transpose. Here. So now tell me, when I do A backslash B, the first element is D. The second element is C2, right? Because I'm solving this equation. D plus C2 times log of x. So the first element that I get is D. The second element that I get is C2. Now if I want to go back to the first equation, because I want to calculate y, right? What I had before was D equal to log of C1, wasn't it? D was equal to log of C1. So C1 is equal to what? D is equal to log of C1. C1 is equal to what of D? Exponential. So C1 is exponential of D. Isn't it? Make sense? Does it make sense to everyone? So if we want to solve this now, you have a question?
Yeah, sorry. Is it This is x prime from A.
Uh-huh. X prime.
That just like flips your x.
Yeah. So we want to make it vertical. If original is horizontal, you do a prime to make it vertical. So let me just copy and paste x and y into MATLAB. That's my x values. And then my y values. Right? Then I do all sorts of these transformations, not in MATLAB, on a piece of paper, right? I did all the transformations on a piece of paper. I came to this matrix A right here. And I came to this vector B right there. So A was equal to 1s of lengths of x, comma, 1. And log of x prime, because I want it to be vertical. So that's my A. My B is equal to y prime, or log of y prime. This one is D, this one is C2. So the first element is D, second element is C2. So if I call this C equal to A backslash B, right, I'll have the two elements. The first element of C is D, the second element of C is C2. Then I can do C1 is equal to exponential of first element in first element in C is equal to that D, right? So exponential of the first element in the vector C is equal to C1. Does it make sense to everyone? Then the second element is C is C2. So these are my C1 and C2. Bless you. Now that I have my C1 and C2, I can evaluate this equation, right? I have C1, I have C2, I have X. I can calculate Y prediction. Do I have C1? Yes. Do I have C2? Yes. So I have my equation complete. Now Y pred is equal to C1 times x to the power of C2. I go back to the original equation, right? I did all sorts of transformations. I found C1 and C2. Now that I have C1 and C2, I go back to the original equation. Yes?
Are the x and y matrices, those aren't like the x and y values for the model?
X and Y's are the observations. Now we fit a model to the observations. Model is not going to be perfect. So model is not, so Y that comes out of the model is not going to be Y that you predicted or Y that you observed. Do you remember that? Okay. Residual, the difference between your model and what is observed. That's the same concept. So these are the y's that you predict, and these are the y's that were given. Very close to one another, but not the same. Right? So Aaron and Francisco, you got to go back to the video from last session. We are now talking about models that do not go through the data, go in between the data. Because we don't have, if you have 3 points, you have 3 points, you cannot fit a line that goes through all of them. But you can fit a line that goes in between them and is closest to all of them. That's what we are doing in this chapter. Same logic, A backslash B and everything, but now the model, there is a residual. Residual is the difference between what is predicted and what is observed. Is this clear so far? So residual is y minus y pred. That's my residual. RMSE is root mean square error. Is SQRT root mean squared error. Root mean squared error. That's 0.03. R2 is 1 minus sum of residual squared divided by sum of y minus mean of y squared. That's the definition of R squared. 1 minus sum of residual squared divided by sum of y minus mean of y squared. What was the ranges for RMSE? What was the range for root mean squared error? What's the minimum value? You're saying it, Lucas.
I just said 0.
0. 0 is the minimum value for RMSE. What's the maximum value for RMSE? Not 1. Infinity. What is the maximum value for R squared? 1. What's the minimum value for R squared? Infinity. Negative infinity. It can't go to negative infinity. The best value for RMSE is 0. The best value for R squared is 1. Well, you got an R squared of almost 1. So this is close to a perfect model. It's not perfect because we saw there are some residuals. We get a 1 because there is some truncation errors. So if you have a 0.03 that you raise it to the power of 2, you get a 0.009, right? 0.0009. That's very small. That's why you get a value close to 1. It's shown as 1. It's not 1. I can tell you. Does it make sense? Yes.
For the y pred value, do you? No, we just did the first one, the right. Do we do all 3?
All 2 of them.
Okay.
Because there are different transformations, different ways that you need to, different things that you need to do to separate C1 and C2.
Oh, I see. So this whole thing is just solving the first problem.
And then, yeah, the second one is another model. You use the same data, but the model is different. Okay. So let's move on to question 2, Well, it also asks you to plot them. Can you plot these? You have a function. You define your x values. You say like x is linear space of 1 to 20. And then y is equal to c1 times x to the power of c2, right? If you want to plot this function between 1 and 20, you already have c1, you already have c2, right? X is equal to linear space of 1 and 20. Y is equal to c1 times x dot to the power of c2. Plot x comma y. Hold on. Plot x comma y with red asterisk. Oh, y was wrong. It should be x to the power of c2. That's the plot. We got an r squared of almost 1, so that's an almost perfect fit. The residuals are so small that you don't see them. Did we start early? Why is it 10 now? I thought maybe we started at 9:30 and
We're all here.
yeah. Is it clear? I leave the rest of question 1 to you guys. Practice at home. I want to make sure that we do polyfit and polyval as well. We will. Okay. Then question 2. What are the values of unknown coefficients C1 and C2 and C3 in this equation? How do I calculate? I'm looking for C1, C2, and C3. I have to create my matrix A now, right? For question 2. For question 2, my matrix A, the first column represents C1, the second column represents C2, the third column represents C3. What is the coefficient of C1? X1. What's the coefficient of C2? X2. What's the coefficient of C3? 1. Now that's ones, not 1, right? Because it's a column of 1. Ones of what? Length of x1 or length of x2? Or does it matter?
3 by 2? No, 3 by 2.
It's a column. It's not a 3 by 3.
I say 1.
It's a column of ones. But how many ones should I have in there? Right?
Is it 1 by 2?
No.
3 by 1.
It's not 3 by 1 either.
If you say one's lengths of x, why do you have to?
We can do lengths of x because we don't have x. We have x1 and x2. So you have to do lengths of x1 or lengths of x2. Or does it matter? It doesn't matter because x1 and x2 are the same size. Otherwise, they wouldn't be. Well, you need a prime as well, right? Because they are horizontal. We need to make them vertical. They should be the same size. Otherwise, they will not be on the same in the same matrix. So lengths of x1 comma 1.
When you do that, shouldn't it be lengths of x1 prime?
No, lengths of x1 or lengths of x prime doesn't really have a difference. If you have 9 elements, you get 9. Whether it's 1 by 9 or whether it's 9 by 1. Both of them are the same. Yes.
You remember what the comma 1 does after the length?
We want a vector. How many elements do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 elements, right? So I put them, I make them vertical, transpose them, put them on the first column. I have 9 rows, 1 column for x1. x2 the same thing. Make them vertical. I have 9 rows, 1 column. For x3, I need 1, or for c3, I need 1, 1, 1, 1, 9 of them, right? So I have 9 rows, 1 column. Length of x will give me 9. Comma 1 will give me 9 by 1.
Okay, instead of like transposing it.
Well, you know, it's ones, so you don't really have anything to transpose.
Okay.
You just need to create this 9 by 1 vector. Which is ones of 9 by 1. Is it clear? And then, what is B? Y prime. Then A backslash Y prime. How many elements will I have when I do A backslash Y prime? I'll have 3. The first element is C1, C2, and C3. Does this make sense? All right, let's have a look at question number 5. And when we are done with this question number 5, then I can probably give you some time to work on question number 7. Determining water flow through a culvert is a challenging task, as it depends on different variables, including shape of the culvert, friction, slope, potential, etc. Potential obstruction, etc. Shape of the culverts are not necessarily uniform, further complicating this task. One way around this is to measure several water heights and flows and fit a curve through them. The curve can be used for estimating flows given height. So you have a height, you have a flow. You want to use a polynomial to fit this height flow curve. Use polynomials of orders 1 to 3 to fit this data. What does it mean? Polynomial of order 1. What is a polynomial of order 1? Let's see. Y is equal to A times X plus B. Y equal to A times X plus B equal to a to the power of x to the power of n plus b to the power of x to the power of n minus 1 plus c to the power of x to the power of n minus 2 all the way to, I don't know, z. And this z doesn't mean that we have only 32. We can have as many. So this is a polynomial of order n. Polynomial of order 1 is a times x plus b. In this case, flow is equal to a times height plus b. A times height plus b is equal to flow. Now, if you want to solve this using a and b, you know how to do it, right? A is equal to, why don't you do it right now? Just copy and paste that height and flow into MATLAB. A is equal to height prime and runs of height, lengths of height, comma 1. And B is equal to flow prime. And then the unknowns will be A backslash. This is simple. If I want to do this in MATLAB, I just copy and paste height and flow into MATLAB. So these are height and flow defined. A is equal to height prime ones of lengths of height comma 1. B is equal to flow prime, and A backslash B, these are basically, this is my A. Oh, well, okay. Maybe instead of A times height plus B, I should use C1 and C2. That's probably a better choice. So the first element, 5, is C1. The second element, -5, is C2. The two unknowns. There is an easier way when you are dealing with polynomials. There is an easier way that you can estimate those unknowns. It's called polyfit x, or height comma flow comma 1. Polynomial of x comma y comma 1. Polynomial of order 1. That gives me the first, so C1 and C2. Polyfit when you are dealing with polynomials. If you want to calculate RMSE from this, you are going to need flow pred, right? You have flow, you are going to need flow pred to calculate the residual and calculate RMSE. Does it make sense? Flow under my pred is equal to, previously we had this times x, or height in this case, plus this, and that's it. A times height, or C1 times height plus C2. So that would be C1 times height plus C2, or in this case, that's a negative sign. So C1 times height plus C2. That's my prediction. You can do it another way. The other way is called polyval. Polyfit will fit your line or whatever polynomial it is to the data. Polyval will evaluate your polynomial at the data point. For polyval, you got to first give the coefficients, comma, height. Yes. Polyval, you first give it the coefficients, and then you give it the points that you want to evaluate your polynomial at, and it will give you the predictions. Same thing. You want to go A and B, you want to take the coefficients and plug them into the equation, you can. Otherwise, you can use polyval and polyfit, which are easy. So polynomials, polyval, polyfit, make your life easy. Yes.
So for this one that we just did, this is polynomial 1, and then the polyval, the two values that we used there are just for the first one, and then we'll do it again for the second one.
Yes.
Three different numbers.
Yeah. So what we have done so far was for polynomial of order 1. We redo the same thing for polynomial of order 2. So C of C, I do C is equal to polyfit, and the reason that I do C is equal to polyfit is because now I'll have 3 values. It's just easier to put them in a vector and use the vector instead of copy and pasting the values. Polyfit of height, comma, flow, comma 2. Now I have 3, because polynomial of order 2 is flow is equal to C1 height to the power of 2 plus C2 height plus C3. Right? That's polynomial of order 2. C1 is equal to 1.49. C2 is equal to negative 2.59, and C3 is equal to 1.13. Does it make sense? Doesn't make sense to Joe. Which part?
It just made it way faster than the previous one.
Yeah, so this is only working for polynomials.
Okay.
So if you have an equation that's not a polynomial, you cannot use this. So that A backslash B thing is a general fitting. Can work for polynomial, can work for whatever the input is, whatever the function is. But this is only for polynomial functions. Flow pred in this case is equal to polyval of C, comma, height. This height is basically x, and flow is basically y. Does that make sense? So basically, polyval and polyfit, this is yet another way of finding or tuning those parameters. Polyval, polyfit only for, well, polyfit is to tune and polyval to evaluate your function. When you do polyval of c comma height, what it does, it will take the first element, c1, multiplied by height to the power of 2. And then plus second element, c of 2 times height plus c of 3. That's it. And it will give you all these values. Is this more or less clear? Why don't you take a couple of minutes to solve this question 7? In this case, you cannot use polyval, polyfit. First thing first, you got to load this census data set. So I'll do clear and then CLC load census. When you load census, you'll have two variables, pop and cdate. Pop is population, cdate is date. And then you can use this equation. Pop equal to C1 times e to the power of C2 times date, which is cdate, divided by 1800. Is this a linear equation with regard to C1 and C2? No. Can you make it linear? You should. So take a few minutes to make this linear, find C1 and C2, and predict US's population at year 2050. Well, okay. So it looks like you're going to use polynomials as well. So you're going to have 4 models, polynomial of order 1, order 2, order 3, and this model. Polynomials are easy, so let's skip them aside. Let's use this model. Population is equal to C1 times exponential of C2 date divided by 1800. Use this model, find C1 and C2, and estimate population of the US at year 2050. I'm going to post the pre-exam 2 or pre-practice exam 2 tonight. We'll have a practice exam 2 on Wednesday, and we'll have exam 2 on Friday. If you have any questions, let me know. Yes.
Why are you using pi feet? This is not a polynomial. Well, yeah, you started a polynomial, but when you use a polynomial, that's your function. And that's how you evaluate it. But when your function is, this is a separate function now. How is it equal to C1 times C2? You cannot take C1 and C2 from the polynomial and plug it into this one. This is a separate model.
In the 15 minutes left, let's do it together. Let's take a log from both sides. Log of population is equal to log of C1 times exponential of C2 date over 1800. That would be log of C1 plus log of exponential of C2 over C2 times date over 1800, right? So that would be log of C1 times exponential of C2 date divided by 1800. And then log of population is equal to log of C1 plus log of exponential of C2 date divided by 1800. And that would be log of population equal to log of C1 plus log of exponential, cancel that. Log of exponential. Log and exponential, we cancel it. What you'll have is C2 times date divided by 1800. So now what I will do is I will create my matrix A and B. A is ones of lengths of date, comma 1, and date divided by 1800. And D is going to be log of population. Well, we need a prime here just to make sure. Or I don't know what date is. Maybe date is vertical already. Yeah, if that's vertical, well, yeah, vertical already. So you don't need a prime. Does make sense? Where do you not see, Nicole? Which part of it is not? Log of pop.
Oh, sorry, okay, I could see you said date at first.
Yeah. So we have log of pop. And then when we do a backslash b, the first thing that we get is log of C1. The second that we get is C2. Does it make sense? Yes.
Now that we have both C1 and C2 values, is that when we use the pred, the flow pred or whatever, and then plug in those values to see at 2050?
Yes. So A is equal to ones of lengths of, in this case, my date is C date, right? C date, comma 1. And then I have C date divided by 1800. That's my A. My B is log of population. I do C equal to A backslash B. I have two values. The first element, I need to take the exponential because the first element is log of C1. So C1 is equal to log of the first element in C. Oh man, okay. Oh, exponential, not log. That's C1. And the second element, yes. And C2 is the second element in C. Still have a question, Jen?
Yeah, I just, I'm getting there, I'm not sure why. I have C date loaded and the census loaded and I kept it the same. And then saying it's invalid.
Oh, because you don't write these things to the
I was just like fairly making it, yeah. But shouldn't it like do B or and then typing A and then saying there, and then I need to have B C date.
So you have A and B.
I know, but I was trying to say, well, it's not working.
C1, EXP.
So we got C1, we got C2. We go back to the original equation. We want population at year 2050. So population underline 2050 is C1 times exponential of C2 divided by 2050 divided by 1800 times exponential of C2 times 2050 divided by 1800. That's going to be the population in year 2050 based on our model. Oh wait, no more than that. 1,293 million people. So 1 trillion people. My model is terrible. You get it? Okay. Maybe you just stop putting one another.
Somehow go negative.
Yeah. Does it make sense why I put 2050 there? So that's my model. I can evaluate my model for any point. Now you're positive?
Yeah, I forgot to rerun it once I changed exponential to one.
So that year thing, that C date, you can put any year in there. You want to calculate RMSC and R squared, what do you put instead of 2050 there? When you want to calculate RMSC and R squared? C date. Original C date that we have, you plug it in there. We get the population prediction. We have the population observation. One minus the other is residual, and when you have residual, you can calculate RMSC and R squared. Yes.
The problem is for each model.
Yes, there is a polynomial model that you got to also evaluate. So polynomial over the 1, polynomial over the 2, polynomial over the 3, and this one. You know how to do the polynomials, polyfill, polyval. If you have a polynomial, you can. You have now 4 models. You have polynomial over the 1, polynomial over the 2, polynomial over the 3, these are 3 models. And then you have this model. For this model, you cannot use polynomial, because this is not polynomial.
So what are the other models?
Polynomial over the 1 is a model. I mean, that means A times X plus B. So population is equal to C1 times C date plus C2. That's 1 model. Then population is equal to C1 times date to the power of 2 plus C2 times date plus C3 is another. Polynomial 3 is population is equal to C1 times date to the power of 3 plus C2 times date to the power of 2 plus C3 times date plus C. So each of them is a polynomial model. Let me write them down because that's probably easier to see. So you have the first model. Population is C1 times date plus C2. Population is C1 times date to the power of 2 plus C2 times date plus C3. And then population is C1 date to the power of 3 plus C2 date to the power of 2 plus C3 date plus C4. And then population, the force model is now that exponential thing. So I have 4 models to evaluate. The first 3 are polynomial, so you can use polyval and polyfit and polyval. The 4th model, you cannot use polyfit and polyval. Is that clear, Joe? So you got to evaluate all of them separately.
So for each one, you gotta find all the C values.
Absolutely. And you cannot use C value for the first one for the second one, right? So C1 and C2 for the first one is going to be different than C1 and C2 for the second one. These are different models. C1 and C2 for the first model, done. C1 and C2 for the second model, done. C1 and C2, well, for the second model, you have C1, C2, and C3. And then C1, C2, C3, C4 for the third model, done. C1, C2 for the fourth model, separate. All right. Thank you so much.